Today, we are doing U substitution with integration. All right, but today we're adding something. How does this problem right here in example 9 look different than what we've done so far? There are bounds now. Okay, remember, when we talk about bounds, I've got bounds. This is a definite integral. All right, so this is not going to be the same thing we were doing with the plus c. If you need other notes, there's more in the tray. We are doing this with bounds. It doesn't change a lot. In the end, your answer actually looks a little bit cleaner, which I kind of enjoy about them. We look at this first problem. We're integrating from 0 to pi over 4 of tangent x secant squared x dx. First thing we need to do is recognize that this is a U sub problem. And it might be a little bit tougher. Take a second with your neighbor. You are trying to identify what U is. But remember this. Whatever you say U is, you're going to take the derivative of that, and it's got to plug back in and cancel out. So think about that for a second. Make a distinction. What do you think U is going to be? Here we go. We are finding U on this problem. It is not secant squared. It is not secant. Anybody know what the U is going to be? Stuart, what do you think? Tangent. Why do you think U is going to be tangent x on this problem? du over dx. This one's tricky. Most of the time we talk about the baby, the thing inside the parentheses, but this one's tricky. U is tangent x. Du over dx is going to be the derivative of tangent, which is secant squared. That's why we picked tangent. It's secant squared. When I solve for dx, I'm going to multiply both sides by dx and then divide by secant squared. It's going to be du over secant squared x equals dx. All right. What that's going to do is when we plug it back in, that secant squared x on bottom is going to cancel out with that secant squared x in the integration, which is good because now it's gone away and that's what we want. Everybody clear with that? If this were a normal indefinite integral, that's all you would have to do. But because there's bounds, we have another step. This is really important. These bounds right here, this pi over 4 and that u, those are bounds in terms of x. They are written in this problem to be x bounds. What we are going to do is we are going to change those into u bounds. And this is all this means. We are going to find new upper and lower bounds. My upper bound before was pi over 4. But now we're going to take that pi over 4 and we're going to make it a u bound. So what that means, bless you, is we are taking pi over 4 and we are going to plug it in for x in my u equation. So I'm plugging it into this equation right here. I'm going to plug it right there for x. And so it's going to be this, tangent of pi over 4. So think about your unit circle. You're at pi over 4. You're doing y over x. What is y over x going to be right here at pi over 4? 1. It's radical 2 over radical 2. It's going to get you 1. That's going to be my value there. Tangent's going to be 1. That's my new upper bound. We're going to do the same thing for my lower bound. So for my lower bound, it started off as 0. This time I'm doing tangent of 0. I'm taking that 0 and plugging it into that u equation for x. So think about your unit circle. You're at 0. You're doing tangent. It's y over x. What's y over x going to be at 0? It's going to be 0. It stays 0. Cool. So my new lower bound is 0. Now that we've done that, it might be a little bit annoying. We get to substitute all of those things in, and it's going to make this problem really easy. So let's set this up. I'm integrating. My lower bound is now 0. My upper bound is now 1. I'm substituting everything. It's not going to be tangent x anymore. Now it's going to be u. Secant squared x, I'm not substituting anything for that. That's still secant squared x. But for dx, I'm going to plug in what dx is, which is du over secant squared x. So again, this is why we picked tangent as our u. Because now before I integrate, I want to make sure that I just have u's and not x's. What can I do? Cancel out the secant squares. I got a secant squared on top and bottom. It goes away. So now my problem is just this. Integrate from 0 to 1, u to u. We just integrate. Don't forget to integrate. It's u. I'm integrating it. So I increase my exponent by 1, so now it's going to be u squared. And I divide by my new exponent. A half u squared. It's not plus c anymore because it's not indefinite. This time we're evaluating this thing starting at 0 and going to 1. So I'm just going to finish that. That's easy. Don't let that be hard. I got a constant, so I could pull that constant out in front. Upper bound minus lower bound. I plugged 1 and squared it, minus 0 squared. 1 squared. 1 minus 0 is 1. Times a half. My answer is 1/2. I went through that a little quick. Think about what I just said and make sure it makes sense to you. All right? Again, here's what we did. We found our u. We found du dx. We found our derivative. So why did I not have to plug it back into tangent? Because I don't care about tangent anymore. All right? Remember, the answer in the end is a numerical value. And so all I want is a numerical value. When we changed it to become u-bounds, I don't care about tangent anymore. I did the plugging back into tangent right here by changing my upper and lower bounds. You could do it the other way, Stuart. We don't want to necessarily do that, and we'll show you why here on the back side because of the way the AP exam does it. Yes, sir. Once you change u-bounds, you don't care about x anymore because it doesn't apply because we already did the plug-in stuff. That's what Stuart just asked. We plugged in. We took pi over 4 and we plugged it in to get 1. We just did that process earlier instead of later. It just made it easier at this point. Everybody okay with that first way through? Let's try another one. So let's look at example 10. So looking at example 10, we're going to start off by finding your u, and then you're going to find the derivative, and then you're going to solve for x. Take a second with your neighbor. Identify your u and your du dx. My u value is going to be just cosine. Here's why. My last class, anybody want to try to explain why it's just cosine? Kyle, what do you think? That's a great answer. That's a great answer. My last class said it 2 answered. It was perfect. What you just said was great. The derivative of cosine is sine. And so if we take it's negative sign, but it's going to cancel out. By understanding that, it's going to be helpful. And the other part is it's our baby. The cosine's inside the parentheses because it was cosine of x all squared. And so both of those 2 ideas together is what's helping me to identify u. It's the thing inside the parentheses. It's the cosine. And also because I know the derivative of cosine is negative sine. Negative sine x. And when I solve for dx, I'm going to flip those 2 spots. It's going to be du over negative sine x dx. There is equal to dx. So Kyle knows that when he plugs that du back in here in a second, that sine x and that sine x are going to cancel like we want. While we're at it, let's go ahead and change some bounds. And so I want my upper bound. I want my lower bound. Find what those 2 values are going to be. We had an upper bound of pi. Show me with your fingers what's your new upper bound going to be. It was pi. Now it's going to be -1 because I'm doing cosine of pi because I'm plugging it in right there. So cosine of pi, that's over on the left side of the unit circle. My upper bound is now going to be -1. My lower bound was 0, but now I'm going to do cosine of 0. I'm plugging it in there for x. Show me with your fingers what's your new lower bound going to be. Cosine of 0 is 1. So I'm doing some substitutions now. I'm going to plug in u. I'm going to plug in for dx. I'm going to plug in my upper and lower bound. Take a second, plug those in, see what you get. We're substituting in here. And so my new bounds are going to be Upper bound is -1. Lower bound is 1. I'm plugging in cosine is going to become u. So this is now u squared. Sine x. For dx, I'm plugging in what dx is, which is this guy right here. Du over negative sine x. Now that we've done that, let's start to simplify. Aaron, what can I do to simplify that? What's something I can do? You could flip the bounds. Absolutely. We want the upper bound to be bigger. And so if you flip the bounds, she's going to make it a 1 on top and a -1 on bottom. And if you flip the bounds, what else are you going to have to do? Perfect. All right, so she flipped bounds. Good. Haley, what else can I do here? They got a sign on top. We got a sign on bottom. We want it so that there's no longer a x and a u in the problem. We cancel that out, so now I've just got u squared, which is what I want. What other thing can I do here? Cancel out the negatives. Yeah, either way you want to talk about it. He's got a constant of a negative right here. And so RF knows if he pulled that -1 out in front, it's going to cancel with that negative we got when Aaron flipped the bounds. And so now it's a positive back in front. It's going to cancel each other out. However you want to talk about it, that's fine. And so there's my setup, and now it's du. We did a whole lot of simplifying. We're not done with this thing, though. The number one thing we forget on U sub integration is the integration step. Everyone's to this right here, and then we always just start plugging in bounds. Can't plug in bounds yet. What's your next step here? Integrate. Take u squared, increase the exponent, divide by your new exponent. Get an answer for that. When you get an answer, show me with your finger so I can check your work. U squared becomes u cubed. I divide by my new exponent, it's 1/3, and I'm evaluating that thing from -1 to 1. I'm plugging in my upper bound. So I've got this constant of 1/3. It's 1 cubed minus, I'm plugging in -1. I'm cubing that as well. So I plugged in upper bound and lower bound. 1 cubed is 1. -1 cubed is -1, but it's minus -1, so it's +1. Times 1/3, that's 2 times 1/3. My answer is 2/3. Most of us were pretty good at that as I checked. We okay so far? Let's try one more to make sure we're doing it right. Again, it's not a lot of change. Once you've done this once or twice, it's going to be continuing to be about the same level of difficulty. You just got to make sure you don't forget little things. Okay? Let me erase that real quick. Try number 11. You got that thing right there. You're setting up your u. Set up your du dx. Find dx. Find upper and lower bounds. You got a little bit of work there. See if you can do that. Once you've done all the u part, everything else is pretty easy, but you got to get through that u first. I liked where we were at. We got to this point well. Now we're going to plug in. So my new bound is 1 and 9. X squared didn't go anywhere. The only thing there were two things that I saw as I walked around. This is u to the 1/2 power because that's u and it's square rooted, so it's 1/2. Dx is going to be du over 3x squared. That's this guy right here. So I want to cancel out x squareds. I got an x squared on bottom, x squared on top. Those go away. Where is that 3 when I set that up? It is 1 over 3, and so that is a 1/3 in front. All right, some of us made it become 3. Don't do that. It's a mistake that's common, though. We get to that point. Then I'm integrating u to the 1/2 power. I'm adding 1 to my exponent. So now it's u to the 3/2 power. I'm dividing by my new exponent, and so it's like multiplying by 2/3. And I'm evaluating that thing from 1 to 9. My handwriting got bad there, sorry. 2/9. And I am plugging in, and so it's 2/9 because of this part. U to the 3/2, so it's 9 to the 3/2 upper bound minus 1 to the 3/2. That's lower bound. 3/2 power, that is like square rooting it and then cubing it. 9 square rooted is 3. 3 cubed is 27. 1 to the 3/2, that's the square root of 1 is 1, and 1 cubed is 1. And so I get 2/9 times 26, or in other words, 52 all over 9. Questions on that guy? Let's do 2 more here and we'll be done for the day. Example 12. So think about that four corners activity that we do quite often. And then one corner there's graphs, and one corner there's tables, and the bottom corner there's algebra, which is what we've done all day today, just straight plugging in. And then in the other corner is conceptual. All right, where that conceptual one is always the bottom left. Everyone tries to stay away from that corner because it's a little bit tough. This is a conceptual question. It is easier than the ones we've done so far. Don't let conceptual questions slow you down. You are integrating with definite integrals. All right, you know how to integrate with definite integrals. Is this problem a U sub problem? I would say yeah. What about that problem makes you think it's a U sub? There's a function inside of another. There's a composite function. There's a baby. There's a baby inside there. That baby is the 2x. That's going to be my U. So take a second. Find, I'm telling you what U is. U is 2x. Find the derivative. Find what dx is, and then find your upper and lower bounds. Go. We're finding the derivative. Franny, what was your derivative here? 2. And so what was dx going to be equal to? Yep, du over 2 is all equal to dx. Show me with your fingers what's your upper bound. Upper bound is 6 because we're taking that 3 in my upper bound and plugging it into the 2x. And so 3 times 2 gets me 6. Show me with your fingers what's your lower bound. 0. Now all we're doing is plugging it in. So plug it in. All we did was we plugged in. Do I have any constants? Half. I can pull a half out in front. That's easy enough. 1/2. Integrate 0, 6. F of u. du. And then we do it. What's our next step? Integrate. Find the antiderivative. We're going to take the antiderivative of f of u. What's the antiderivative of f of u? Capital F of u. That's a thing. Capital F of u, 1/2 capital F of u. We're going from 0 to 6. All that's left in this problem is what? Plug it in. That's the only step left. My answer to this question is 1/2. That's a constant, so I'm going to multiply it. Capital F of 6 minus capital F of 0. That is it. That is a conceptual question where they're trying to say, do you just know how to do U sub or do you understand the concept? We understand the concept. We figured out what U is, we changed our bounds, and we plugged it in. Questions with that guy? Grab your whiteboards. This is why we do these problems. These are getting to an AP question. This is from last year's AP exam. See what you can do with it. Using the U substitution, U equals sine of 2x. Figure out which one's equivalent. Do that now for me. We're setting this guy up. I found U. I found the derivative. I found that. One of the most important things I'll tell you on the AP exam is look at the multiple choice answers. My multiple choice answers over here all still had U in them. They didn't integrate. This is not a true calculus question. It was a setup of a calculus question. So since U was still in it, I definitely need to change my bounds to be U bounds because there's nothing about an X in anything over here. And so my U bounds need to have new upper and lower bounds. So my upper bound was pi over 2. And so now I'm going to take pi over 2 and do sine of 2 times pi over 2 because I'm taking that pi over 2 and plugging it in for x. What happens with my 2's? They're gone. And so it's sine of pi. So here's pi over here. If I'm doing sine over here, that's going to get me 0. I do my lower bound. So for my lower bound, I'm doing sine of 2 times pi over 6. So that's the same thing as pi over 3. So think hand trick, pi over 3. That's that guy right there. I'm doing sine. It's radical 3 over 2. And so when I set this guy up, I'm integrating. I'm going from the upper bound and the lower bound. It's now going to be this guy. It's u to the 5th cosine of 2x. And I'm going to plug back in what this thing was. Du all over 2 cosine 2x. What's going to happen with my cosines? By? Do I have any constants? A half. Do you like the bounds right now? Sure is the right answer. No, you don't like them. And most of you started to switch them already. But look at your multiple choice answers. That thing right there just said what was equivalent. It doesn't say what was the proper form. That thing right there is exactly the same as D. On C, they flipped them. But what's wrong with C? It's not negative. They're trying to trap you in on that one. Don't pick C. Make sense on how we did that?